All right, today we're going to work on lesson 4.3, the last of our rigid movements here, and that is doing a rotation. And we're going to focus primarily on doing rotations around the origin today. And again, these are rigid transformations, which means the original figure and the what we call the pre-image and the image, our result, they are identical to one another. All right, so let's just take a look at what this means. If we were to rotate excuse me, if this is about rotating a point and then finding its given coordinates. All right, what they're showing us is this parallelogram is drawn up here in quadrant one, and the original point here is at 1, 7. They want us to rotate the figure 90 degrees counterclockwise around the origin, and then give the coordinates of the mark point in the original figure and then in the final figure. So what I want you to think of is if this was a piece of paper that we had in front of us and we could put a pin in it right here at the origin, we want to rotate this 90 degrees counterclockwise. So we want to take this blue line and we want to rotate it up until the blue line is here. Okay. And if we do that, where does this shape go? So what I'm going to show you is kind of a version of that rotation. So let's say we got the pin here and I'm going to rotate this slowly up until this blue line is here. That'd be 90 degrees counterclockwise. Okay. So if I start to turn it, continue to turn my shape. All right. If I get the blue line moved up here, then the shape rotates down to this position. Okay. So it started like this again. And when I did the rotation, I wound up rotating it down 90 degrees counterclockwise. All right. That's what a rotation is, like sticking a pin in it and actually spinning your paper, on that pin. So the original point was at 1, 7. Our rotated point here now is at -7, 1. And don't worry, we're going to get into rules as to how we do this later. We're just kind of getting the overall concept right now. All right, let's do another one here. So we got a figure in the coordinate plane. This one's in the second quadrant. We're going to rotate it this time 90 degrees clockwise about the origin, and then give the coordinates of the original marked point and then the new marked point. So if I'm going to go clockwise, think about taking this blue line and we're going to rotate it down this way. So we're going to stick a pin in the middle of it here, and we're going to turn our paper so that we get it this blue line down here. That's 90 degrees clockwise, right? 90 quarter turn. Okay. So if I kind of do that here, I stick a pin in this and I kind of rotate it around. There's what the image would be. Remember, it started up here, and as I rotated it 90 degrees clockwise, it's going to move into this position. So the original figure looked like this. When I rotated it, guys, it looked like this. Okay, again, I took that blue line and I rotated it down, as you can see over here. Ask the question now, what's the original point? It's at -5, 6. What would be our new point? It would be at 6, 5. We're going to get into these rules. It's going to help you with this here in a bit. We're just trying to get the overall concept right now. Okay, so this one asks us to rotate the figure 90 degrees counterclockwise about the origin, then decide if these statements are true or false. So again, 90 degrees counterclockwise, this blue line is going to rotate up to here. So this image is going to rotate from the third quadrant into the fourth quadrant. Okay, so if I do that rotation, okay, again, I'm sticking a pin in it and I'm going to move this line up, right? So I'm going to rotate, rotate, rotate. This is where the shape would go. Again, we said it started in the third and we're going to rotate it into the fourth quadrant. So it started here, we rotated it to here. Now let's answer the questions. If two sides are parallel in the original figure, then they are parallel in the final. You know that's true because these two are the exact same shape. The final figure measures, angle measures are the same as the original angle measures. True, they're identical shapes. The final side lengths are longer than the original side lengths. False. The original figure and the final figure are congruent. True. Okay. So we know that we've been working with that rigid concept. These are rigid transformations, and these questions are very similar each time. All right. All right. Let's determine if I could take this figure and rotate it to this figure. So if I had, again, let's talk about the blue line. And guys, you can rotate clockwise or counterclockwise. But if I rotate this one 90 degrees clockwise, I'm going to move from here to this quadrant. Okay, I'm going to go from the second to the third quadrant. So it's going to take more than just a 90. All right. Now, if I do the movement to try to get it as close as I can, it would actually be this movement. Now, this is a 90 and then a little bit more past 90. So this is kind of hard to do. It's kind of hard to see. But you can see this image when you rotate it. Okay, if I go back, as you rotate the image, you know that the top of this is going to start rotating down to the bottom. Okay, so you know this image, this blue one, is not going to fit on top of this dashed one. Okay, that one's not possible. Now this one, okay, if I rotate this one, all right, let's say I'm rotating it down this way. I know if I go 90 degrees counterclockwise, I'm going to move down in here. And if I keep going, I actually can lay that one right in here. Now they went the other direction, right? You can go either way, but they went this way and they see that this is going to lay right on top of that one. So that one is possible. Okay, now let's talk about some rules here. When you rotate shapes around the origin, then there are rules to doing these. Now, what we're going to look at, though, guys, is specifically three different types of rotations. All right, and in these three different types of rotations, we have some set rules. So if we rotate 90 degrees clockwise around the origin, okay, now 90 degrees clockwise is the same as 270 degrees counterclockwise, 270 degrees counterclockwise. If we do one of these two rotations, they're the same. What happens is our ordered pairs would go from an AB to a B opposite of A. So I interchange the coordinates and I make the A its opposite. And that would be the new location of the point in a 90 degrees clockwise rotation. I'll show you examples of this in a second. Okay, but you need to know the rules. You need to write these down and use them to help you. Okay, 180 degrees clockwise is obviously the same as 180 degrees counterclockwise. It's a half a turn. So whether you go half a turn clockwise or half a turn counterclockwise, you are in the same spot. Okay, the rule for this one is you take your ordered pair, let's say it's AB, and you're going to make them both their opposites. Okay, so AB becomes opposite of A, opposite of B. That will be the location of that ordered pair after a 180 degrees turn around the origin. Okay, the last one is a 270 clockwise, which would be a 90 degrees counterclockwise. Okay, that's a 3/4 turn clockwise. It's the same as a quarter turn counterclockwise. Okay, the rule for this one is AB with an ordered pair, AB would become then opposite of BA. Opposite of BA. And it's easiest to see these in an example. Now, you're going to want to write these down and use them, but let me show you what it looks like, okay? They give us this figure, and they're saying you need to draw it after a 90 degrees clockwise rotation about the origin. All right, so 90 degrees clockwise. Remember, clockwise, just like a clock works, is like this, right? So a clockwise rotation is this way. So this is going to move 90 degrees this way. It's going to move up into the second quadrant. What I want to do first, though, is I want to identify the ordered pairs that represent the vertices of my triangle, right? So X is at -5, -4. Y is at -3, 1. Z is at -2, -5. Okay. Now, the rule for 90 degrees clockwise is your ordered pairs switch to the, it goes from AB to B opposite of A. So this first one, I want to just find its new coordinates. They would become, again, B, so the -4 is now first, and then opposite of A. So A was -5, now it's +5. So my new X position is -4, 5, X prime. Okay, do the same thing with Y. Interchange A and B, make A its opposite, so it's going to be -1, 3. For Z, interchange A and B, make A its opposite, it's at -5, 2. Now I'm just going to graph these points, and there is my rotation. So a 90 degree clockwise, I'm going to rotate from here up to here, and I'm going to follow the rules and locate my points. That's why I said write the rules down. Okay, let's do another one here. Draw this triangle after a 90 degree counterclockwise rotation. So 90 degree counterclockwise means I'm going to go from the second coordinate up to the first. Okay, counterclockwise was moving that way. All right, so again, first thing I do is identify the vertices. I give them a label, and then I find them. So X is at 1, -4. Y is at 2, -1. Z is at 5, -3. What's my rule? Well, a 90 degree counterclockwise, which is the same as a 270 degree clockwise, the ordered pair goes to opposite of BA. So this first one, X, is going to become 4, 1. Again, interchange these two and make B its opposite. Okay, interchange these two and make this -1 its opposite. You get 1, 2. Interchange them, make A its opposite. You get 3, 5. Take your new coordinates and graph them, and you can see that's a rotation 90 degrees counterclockwise, which would be 270 clockwise up into this quadrant. Okay, so that's doing it according to the rules. Finally, they'd like to work through the definition here. All right, so notice that we're going to start with GHI, this triangle, and we're going to rotate it. It looks like 90 degrees clockwise down here into to create triangle H prime, G prime, I prime. Okay, and they list the coordinates for us. Okay, and you can see the coordinates. See how the G is 1, 8 and G prime is 8, -1. They kind of switched them and changed one of them. Same thing for H, same thing for I. Okay. All right, the first question says, suppose each pair of segments have the same length. So they're saying C to G and C to G prime are the same length. What is that length? Well, this is distance formula, right? G to C, you find their ordered pairs, or remember I taught you the right triangle concept in Pythagorean theorem. Okay, so I want to check G to C, C to G prime, and those are both the square root of 65. Notice, give exact answers, no decimal approximations, write the square root in there. Okay, C to H, C to H, and C to H prime. Okay, I could write out the ordered pairs and use distance formula. I could use the concept of a right triangle and use Pythagorean theorem, and I get an answer, the square root of 34. These two are the same length. And C to I prime, they're the square root of 72. So what are we showing here? We're showing you that the points are the same distance from the center. Okay, the center is the C. C to G prime, that's the same length. That's what we're trying to get out of that. Okay, same concept. Now, suppose we were to measure the angles created from G to C to G prime. Can you look at that? G to C prime. And look at H to C to H prime and I to C to I prime. Now, they give you a protractor that you get to use in the program. And what you're going to find, remember, we said this was a 90-degree clockwise rotation. Well, the angles created from point to center to point are all 90 degrees if you put a protractor in there and measure. Okay, 90 degrees rotation. And then last of all, choose the pair of statements that are going to be correct. And I'm going to go right down here to this one. It says each point on the original figure is the same distance from the center as its rotated image. Yes, that's what we did in part A. All angles formed by a point and its image with the vertex at the center of the rotation are congruent. They're all 90 degrees. That's what I want right there. Okay. All right. So that's all the concepts for rotations. You have the rules. Make sure you write them down. Homework's on Alex, and I'll let you have it.